everybody is here, am I right? Okay. So first we will perform the test for carboxylase. So normally the students take about 1 ml, 2 ml of bicarbonate solution in a test tube, and then they add the substance look for the effervescence. Right. So the same thing we are going to run a tile itself. As I told you, all non-heating experiments will perform on the tile itself. All non-heating experiments. So I think a little of fun. And because now you have more people are here, I will take a little more. Okay? Actually, it is enough just to take half of what I have said. For a single student, it is enough they take just half of what I have. But because now we are take a little more. Now please I will add sodium bicarbonate solution. 10% sodium bicarbonate solution. Do you see the difference? Yes. What else do we need? Because it's only qualitative analysis. We are looking for only some observations. We are looking for only some observations. So our observations here bicarbonate effervescence. And we are able to have the effervescence. Not only that, when we use just only one drop, the sodium salt of the acid will remain acids. Maybe we will have a buffy mass, just like a cake-like structure. The initial physical state of the substance will be changed. The initial physical state of the substance will change. And more importantly, we are using just only one drop. And because one drop we need, we use this type of formula. See, this will run for the entire year. This is run for the entire year. When we are taking only one drop. Yeah, it's because it will be easy for handling. You can have even glass bottles, but a smaller size bottles are not available. And in case of such colored reagents, if the color of the reagent gets tarnished or the color changes, you discard it. Till then you can use it. See, all these reagents have got sufficient self-life. You can use this for months together. 1 month, 2 months, it will be there. No problem. And if it changes color, especially the color reagent, you have to change it. Otherwise, you can keep the same reagent. No problem. So this will run for a semester. If you continue any reagent, you can continue using fluorescence. They need not be prepared as such. Then we perform the test for diagram. See how I am going to do this. Normally the students take about 50 milligram of the substance, then they add equal amount of see, the only thing is whenever you are using any heating instruments, make sure that you do this dry. That's the only precaution you have to take. So we will take see, I am taking only very small quantity of substance. Right? Now I have to add an equal volume of resorcinol. Now normally students take about 50 milligram or 100 milligram and they add equal amount of resorcinol, and then they normally use 1 ml sulfuric acid minimum. Generally students use 1 ml, half ml, and then they pour the entire lot into the paper. Because concentrated sulfuric acid is like normal. So to utilize that, you have to provide large quantity of sodium hydroxide. And only when the acid is utilized and the medium becomes alkaline, the lactone ring will open and will bring hydroxide. But here in this case, what we are going to do is, we are going to do the same thing with just only 1 drop of the acid. And even in that, the reaction mixture will take just a peck on the tip of a glass. So, we hardly require So I will take the same quantity of the sauce now. We'll add this. Okay. Now to this I will add just only 1 drop of sulfuric acid. Now before that, I have to get rid of the dilute. So what I will do is, I will take about 2 ml of water. Okay. I take about 2 ml of water. To this I will add just I will add just 2 drops of 50% sodium hydroxide. Just a little bit, once or twice. Yesterday we did all these experiments. Yesterday we actually tested the reagents. So somehow. So I am adding just 2 drops of 50% sodium hydroxide so that I will get the dilute sodium hydroxide is ready now. See, we have labeled everything like this. So the idea is not to mix the droplets because there is every chance the droplets may get mixed up. So we use labeled droplets. So I need just only 1 drop. As I told you, because it is a small tube, and again I am taking only very small quantities of substance, there is no need for this conventional Bunsen burner. The heat supplied by this itself is more than sufficient. You can see for yourselves. See, the reaction is over. Okay, and after once the dissolution occurs, we can warm it again. This is over. Now I take a peck of this, the tip of a gas rod. We introduce this into the test tube containing dilute sodium hydroxide. You see that? That's all. Because the quantity of the acid solution is minimum. Again, so we require minimum amount of sodium hydroxide. Because the conventional method use large quantity of acid, so we need large quantity of sodium hydroxide. This is what I meant. That is macroscope, this is microscope. So the fundamental chemistry is the small
ഞാനൊരു സ്റ്റോറി
അവിടെ ഒരു കസേര ഉണ്ടാവും, അവിടെ ഒരു കസേര ഉണ്ട്.
Except reduction of quantities. Except reduction of quantities, I didn't make any other change. Right? That means the chemistry should be the same. The answer should be the same. But why people are hesitating to accept this idea?
ബ്ലോക്ക് ഉണ്ട് അവിടെ തന്നെ.
The convention. See, in the conventional method, to perform the aromatic primary element test, we have to cool all the solutions in iso. What is the purpose? The test tube is a closed container. The test tube is a closed container. You are performing an isotopic reaction. Say you are using HCl, you are using sodium hydroxide solution. That means strong acid, strong base. Nucleation is heat of nucleation is more. So you have to cool it. Suppose you don't cool that, because the dye is heat sensitive, it will discharge. That is the reason why we have to cool all the solutions. Again, you prepare sodium nitrate afresh. In many colleges, thank you. Thank you. Thank you. So, they prepare even alkaline mineral alcohol afresh. See, whenever you prepare anything, you prepare just the required quantity. Definitely we prepare more. Then what you will do? That's all. Silently you will pour it into the sea. So, whatever it is, whether you use it to the excess, prepare it afresh, it's okay. Because all these solutions have got sufficient sulfur. And in microscale chemistry, we require hardly 1 drop. And a student cannot prepare 1 drop afresh, right? That is impossible. So we can safely have these things. And the advantage of this is there will be no contamination. You are taking 1 drop, just squeezing the bottle out. So there will be no contamination. And another thing, because I am using only 1 drop, the amount of heat liberated will be very, very small. Because the amount of heat liberated is very small, I don't require external cooling. That is the answer for that. Why we are able to have this at room temperature? That is the answer. Because whatever little heat is produced, that will be taken care of by the environment. Right?
Insano.
So you just have land 1 drop. When I land 0.1 in HCl, that is I am preparing amine hydrochloride, right? Amine hydrochloride is prepared. Now I am adding sodium nitrate, that is diazotization. Okay, diazotization is over. Now I can add a drop of alkaline mineral coupling. That's all. What else do you want? See, I haven't made any change. Only thing is I have reduced the quantities. So the chemistry will remain the same. Do you agree or not? It has to be. Because if it is not, then it is logic. Now we will perform the element test. See, you have to instruct your students in such a way that whenever they are going to perform the element test, they should not contain even a single drop of water. Either they have to warm it over a flame or they have to dry it with a waste cloth. Okay? Because in the normal course, there is a conventional method, they will be using fusion tubes. Fusion tubes, because the fresh one, it will always dry, no problem. But here, when they do it in a regular practical classes, they may have test tubes with water. So the procedure will be, you can ask them to, before leaving the lab, they can wash it and keep it upside down, so that the water will be drained. Even if there are drops of water, they can wipe it with a waste cloth. Right? Now I will take little sodium. And we need little excess of sodium than what we normally use to treat. Why? Means, you know, when the organic substances are petroleum origin. Most of the organic substances are petroleum origin. So there is every possibility it may contain traces of sulfur. So ammonium thiocyanate will be formed during the course of the fusion. That ammonium thiocyanate form must be decomposed. So for that we need little excess of sodium, so that it will be contained with innocuous sodium cyanide and sodium sulfide, so that it will not interfere with the color reaction of the elements. Okay? So again, even for this, now people used to say necessity is the mother of invention, right? Am I right? Actually, for the element test, we will use Bunsen burner engine. Once ma'am and myself went to the call see what a particular day the technicians were on leave. No LPG. So we wanted to try this. Why don't we try with this one? That's how it came. So no. So on that day had the technicians being there, LPG was available, then we could not have used this for anything. Okay, so that's how this idea came. And the idea of the heat it will become, you get the metallic lasher. You see the metallic lasher? Yeah, you have to heat it will get the metallic lasher. But the original idea came from Dr. John of the Victoria College, Palakkad. We have extended this. So I will be using as the example for element test, because you can simultaneously test about both nitrogen and sulfur. Okay, now we will put it. See, when the fumes are coming like this, you stop the heat. The conventional way you have to remove from the flame. See, because I have stopped it, now I am not contributing to global warming. So we can avoid global warming this way. So heat it strongly, because there may be moisture content present in the samples, and it is because of this you get this type of mild flame. See, do you see the red hotness of the bottom? Yes or no? Yes, so we can stop the heating. So we have to heat it till it becomes red hot, just like your fusion tube. Suppose the material is strong enough, you may not be able to see the red hotness. But what you can see, observe is whether there is no vapors coming out. So if you are not sure, you will keep it with you more, no harm. Okay, stop the heat. So now the fusion is over, right? Let us keep this here. We will perform the other test.
Cautious.
Very good. This is what we prepare. See, I am going to now test it for acetophenone and there is a ketone and the oil. And because both of them are carbonyl compounds, now how to distinguish these two, one from the other? You please tell me which is which. Unlike the conventional method where we use for the alcohol used in the substance and the reagent, heated, cooled, and then we add 1 or 2 drops of concentrated HCl to get the red orange precipitate. Now the very same reaction I am doing without any heating, and again directly to the substance I am adding the reagent. So you will add just 1 drop of the reagent only, the post reagent. Now which case the color is dark? This one or this one? First one or the second one? First one, isn't it? The color is little dark, right? Agree? Okay. Now why it is dark? Both are carbonyl compounds. This is because in the case of a ketone, you have extension of conjugation. Now I have taken acetophenone, that means you have hyperconjugation. There is an aromatic ketone, that is both of them are aryl rings, then in that case it will be pi conjugation. Anyway, either you have hyperconjugation or pi conjugation. So conjugation will lead to red shift. That is, the color of the substance will get different. So that is why the DNP is a little dark here, whereas the DNP here is slightly lesser than that. So we can easily distinguish between an aldehyde and ketone by this simple test. There is no need to run a spectroscopy. See how many tests we have performed. 4 tests, right? See, in this single row. Now I have got so much space left. I am going to perform the other test. Now by this time, we have come to room temperature. Now keep the tube like this randomly. See, keep the tube like this landingly, and add little water, just 1 drop of water. Allow that to trickle down. Why? So you add 4 drops like this. Sometimes you know what happens, when you add like this, it may give like a pasty mass. In that case, what you can do is, you can add 2 more drops of water, that which is sufficient. Total 6 drops is enough. You stir it to the glass rod, okay, make it into a solution. Now the sodium fusion extract is ready. There is no need for any filtration. See how easy they are preparing. See, the conventional method, we heat it minimum 15 minutes, isn't it? To concentrated solution, we heat minimum 15 minutes. So that 15 minutes of LPG you are not using it. So 15 minutes for one student, 15 into 40, 600 minutes of heating you are avoiding. In a single class, you are avoiding 600 minutes of heating because each student has to perform the element. That means everybody has to heat it for minimum 15 minutes. That means 600 minutes of LPG you are saving by this single test. You can see the advantage of this method. So study it well.